Hello, I believe I can show you how to factor the function x to the fourth minus 2x cubed plus x squared minus 72x minus 1260 completely. And we should use several properties of numbers and the fact that x equals negative 6i is indeed a known root. Okay, so first of all, notice that because the leading coefficient is 1 on the x to the fourth, we can look at factors of negative 1260 as possible factors for this problem. So let us perform the prime factorization of 1260. Now 1260, the digits add up to 9, so that means it should be divisible by 9. And it is, and the result is 140. Well, 9 prime factorizes into 3 times 3. 140 prime factorizes into 14 times 10. 14 prime factorizes into 2 times 7. 10 prime factorizes into 2 times 5. So the prime factorization is 2 squared plus 3 squared plus 5 times 7. Okay, so if all those are multiplied, first of all, these are possible real or maybe even imaginary factors of 1260. If x equals negative 6i is a root, then x equals plus 6i is also a root. Imaginary numbers always come in conjugate pairs when factoring a real polynomial. Second, then the factors will be x plus 6i times x minus 6i, which if you multiply that out by a difference of squares is x squared minus 36i squared. But I squared we know to be negative 1. So negative times negative is positive. That's x squared plus 36 is a factor. Notice 36 is also 4 times 9, which is 2 squared times 3 squared. So it seems to be that 5 and 7 are good candidates for possible real number factors of this polynomial. So let us try negative 5, that is x equals negative 5. So x equals negative 5 for synthetic division. Now synthetic division is where we write down the coefficients of the polynomial and we perform this algorithm with negative 5 in the upper left-hand box to see if we can divide out evenly. So the 1 comes straight down. 1 times negative 5 is negative 5. Add to get negative 7. Multiply by negative 5. Get 35, add to get 36. Multiply by negative 5, that's negative 180. Add to get negative 252. Multiply by negative 5, get 1260. Add 0. Good. So that means it divides evenly. So on the next board, we write down the coefficients that remained, which were 1, negative 7, 36, negative 252. And we write down that x plus 5, which fits x equals negative 5 as a factor. Then let's perform synthetic division on x equals 7 because this last term is still negative, so then this should be a positive to give us a negative factor at the end. So if we try 7, it works because 1 comes down, multiply by 7, get a 0, multiply by 7, add, get 36, multiply by 7, get 252. The 0 that remains here shows us it divides evenly. So we get x plus 5 times x minus 7, those are the factors we've already found, times x squared plus 36. Now, x squared plus 36, we already know that to be our 2 imaginary factors. X plus 6i times x minus 6i, and then our 2 real factors are x plus 5, and then x minus, x minus 7. And this should be the entire factorization of this function. Okay? So hopefully you can see how that works. Now, by the way, part of the reason I knew that negative 5 and positive 7 were good candidates was I graphed this polynomial on the sophomore Desmos. And notice x equals negative 5 and x equals 7 were good candidates. So that's why negative 5 fits into this factor and 7 fits into this factor. Okay, I hope that was helpful.